Hello friends, welcome back. I gave you some questions to be done in the morning and I think we should be now discussing them. I'm sure most of you must have tried the questions at home and come up with some answers. In case you haven't done that, I would recommend that you pause the video, do the questions, and then we'll be discussing that over here. Then you can watch the video, that is. Okay, so I'll just give you a brief recap of what I did in the previous class. I told you that if I have a polynomial in x which is of the standard form ax square plus bx plus c, and if this polynomial has two zeros alpha and beta, then alpha plus beta can be written as negative b upon a and alpha beta can be written as c upon a. And I wanted you to check this information and verify this for these polynomials. These are the first these are the 10 subparts of, I think, question number 47 what I gave you on the group in the morning today, right? So these are the polynomials that I've written, and we are going to find the zeros for each of the polynomial and verify. Well, I'll not do all the questions. I'll do the ones I feel are a little difficult, and you can follow the same steps for the other polynomials as well. All right. So let's start with the first one. I'll do it here. The first polynomial is 4x square minus 3x minus 1. Right? I can split this, and the first step is equating px to 0, which implies 4x square minus 3x minus 1 equals to 0. By splitting the middle term, I will get 4x square minus 4x plus x minus 1 equals to 0, which gives me 4x into x minus 1 plus 1 into x minus 1 gives me 0, which is x minus 1 into 4x plus 1 equals to 0. If x minus 1 equals to 0, then x comes out to be 1, that means alpha is 1. And if 4x plus 1 equals to 0, this gives me x as negative 1 over 4, that means beta equals to negative 1 over 4. These are the values of alpha and beta, the zeros of this polynomial 4x square minus 3x minus 1. What I have to do now is to verify the relation, right? So what we'll do is, I'll find out alpha plus beta. From this information over here, I know that alpha plus beta should be 1 plus minus 1 upon 4, which is 3 by 4. Right? And alpha into beta will be 1 into minus 1 upon 4, which gives me negative 1 over 4. Right? Now, if I look at the polynomial and if I try to verify this relation, simply alpha plus beta gives me negative of b. b is the coefficient of x, in this case is negative 3. So minus of negative 3 divided by a, which is the constant, which is the coefficient of x squared, which is 4 in this case. So minus negative 3 by 4, this is 3 upon 4, and this is exactly what we have calculated the value of alpha plus beta by actually finding the zeros. So it turns out, in case I have to find out the sum of zeros, I don't have to find the zeros in the first place. I simply can write alpha plus beta equals to negative b upon a, and also, as I'm going to verify this, alpha into beta is equal to c upon a. Right? Let's see. So c upon a, c is the constant term. In this equation, the constant is, so I'll write, one second. Yeah, I'll write this as negative b upon a equals to this. Now c upon a for this equals to minus 1 upon 4, which is negative 1 upon 4. Negative 1 upon 4, and my value of alpha into beta is negative 1 upon 4, which I have verified for this particular question. So as we see, it's not very difficult, right? let's try for another thing, another question. Let's try for this particular one, question number 6 over here. Let me do it for question number 7, which I feel are difficult. In case you want me to do any particular question, you can let me know on the group, and probably I will solve that for you as well. And then I'll do this one for you, the 10th one. Moving on to the next one. There is this question, 4x square plus 5 root 2x minus 3. That's the 6th question that I'm taking. Okay, so let me find out the zeros for this one and verify the relation between the zeros. Okay, so this can be split. So this is px equals to this. Px equals to 0 implies 4x square plus 5 root 2x minus 3 equals to 0, which implies 4x square plus 6 root 2x minus root 2x minus 3 equals to 0. This gives me, I can take out 2 root 2 common from these two terms. 2 root 2 x can be taken as common. I'll be left with root 2x minus 3 plus 3, and then I can take minus 1 common from this, so root 2x plus 3 again equals to 0, which implies root 2x plus 3 into 2 root 2x minus 1 equals to 0. So either root 2x plus 3 equals to 0 or 2 root 2x minus 1 equals to 0. This gives me x to be negative 3 upon root 2, and this gives me x equals to 1 upon 2 root 2. It turns out these are the two zeros that I have. Now, I can take the first 0 to be alpha, that is minus 3 by root 2 as alpha, and beta as 1 upon 2 root 2. Alright, so if I calculate it, I'll get alpha plus beta minus 3 upon root 2 plus 1 upon 2 root 2. I can take the LCM. This is going to be 2 root 2 minus 6 plus 1, which is negative 5 upon 2 root 2. Alpha plus beta over here. And if I want to calculate alpha into beta will be minus 3 upon root 2 into 1 upon 2 root 2, which is negative 3 upon 4. Alright, let's see if these if the coefficients also verify the relation that I've already told you. So if I want to calculate negative b upon a, negative of b. Now b from this particular polynomial is 5 root 2. So this is 5 root 2 upon a, and a is 4, like this. Right? I can write, okay, so I can cancel this. I can cancel root 2 and 4. I'll get negative 5 upon 2 root 2, which is what the answer for alpha plus beta was. Right? And if I want to calculate c upon a, c is negative 3, so negative 3 upon here, upon a is 4, and this also verifies this relation. Alpha into beta is negative 3 upon 4. Alright, so we move on to the next question, which is the 7th one over here. 7th question is the polynomial px, or it's not px now, it's ps, which is 2 into s square minus 1 plus 2 root 2s plus root 2. Alright, so let's expand this. So ps equals to 0 implies 2s square minus 1 plus 2 root 2s plus root 2 equals to 0, which gives me 2s square minus s minus 2 root 2s plus root 2 equals to 0. Right? I can take s common from here. This is 2s minus 1, and I can take negative root 2 common from the last two terms. I'll get 2s minus 1 equals to 0, which implies 2s minus 1 into s minus root 2 equals to 0. So either 2s minus 1 equals to 0 or s minus root 2 equals to 0. This gives me s to be equal to 1 over 2, and this gives me s to be equal to root 2. So alpha in this case is 1 upon 2 and beta over here is root 2. This is the value, these are the values of the two zeros of the polynomial PS. Again, I'll do the same process. Alpha plus beta is going to give me 1 upon 2 plus root 2, which is 1 plus 2 root 2 by 2. Alpha plus beta. And if I want to find out alpha into beta, so alpha into beta, 1 by 2 into root 2, which is root 2 by 2. Right? Now let's verify this. So negative b upon a. Now this entire term is b, including the negative sign. This is b. So negative b upon a will be negative of b. And b is minus 1 plus 2 root 2 divided by a, which is 2. So this negative and this negative cancels out. I'll get 1 plus 2 root 2 upon 2, and this is exactly what my expression for alpha plus beta is, right? Now for the next thing, c upon a. C upon a, c over here is the constant term, which is root 2. So root 2 upon a, which is 2. So root 2 upon 2, and this is precisely what alpha into beta is, right? So this question is also done, right? Moving further, if I want to do the last question, I'm sure you can do the questions in between because they're pretty simple. So I'll do the last one for you, and then we'll move on to the next topic. So the 10th one, which is p of y equals to 7y square minus 11 by 3y minus 2 by 3. Now हमारे पास fractions आ गए अब इसमें, right? So डरने की ज़रूरत नहीं है, fractions हैं. Fractions are easier to deal with actually, right? First of all, let's find the zeros. So py equals to 0. This implies 7y square minus 11 by 3y minus 2 by 3 equals to 0. I can take the LCM on the LHS. अगर मैं LHS में LCM ले लूँ, LCM कितना आएगा इसका? LCM 3 आना चाहिए, right? So I'll get 3 as the denominator, LCM of the denominator. It's going to be 21y square minus 11y minus 2 equals to 0. I'll get the polynomial, the final polynomial is 21y square minus 11y minus 2 equals to 0. Okay. Now, can I split the middle term in this case? I should be able to. Let's see. So, I need to split minus 11y into two terms, which upon adding should give me minus 11y, which upon multiplying should give me the product of the first and the last term. 21y square multiplied by minus 2 gives me minus 42y square, right? So I need the product to be minus 42y square. I'll have to simplify, I'll have to factorize it. I'll have to factorize 42, the numerical value, and find two factors which upon adding give me 11 or minus 11. It turns out the factors are 6 and 7. Now let's do it. So 42, I'll split this, prime factorize it, 21, 3, 7, 7, 1. So 2 into 7, 14, and 14 minus 3 gives me 11. Excellent. So what I can do it, I'll write 21y square minus 14y, because I need a negative sign over here. So this has to be minus 14 and plus 3 in order to get minus 11, right? So minus 14y plus 3y minus 2 equals to 0. 7y can be taken common from the first two terms. I'll get 3y minus 2 and then plus 1, 3y minus 2. I can say this is 3y minus 2 into 7y plus 1 equals to 0. So 3y minus 2 equals to 0 implies y equals to 2 by 3. That's my alpha. And 7y plus 1 equals to 0 implies y equals to minus 1 upon 7. So that's my beta. Beta is minus 1 by 7 and alpha is 2 by 3. Alright, I can verify the relation now. So first of all, alpha plus beta will be 2 by 3 plus minus 1 by 7, which is 14 minus 3 upon 21, which is 11 by 21. Alpha plus beta, and alpha into beta, which is 2 by 3 into minus 1 by 7, which is minus 2 by 21. Correct? Let's verify. What's minus b upon a? Minus b upon a is negative of minus 11 by 3 from this polynomial upon 7, which gives me 11 upon 21. Minus minus cancel होके plus हो जाएगा. 3 into 7 is 21, and I get 11 by 21 as alpha plus beta. So this is verified. Let's move on to c upon a. So c upon a will be c minus 2 by 3 divided by 7. So this gives me minus 2 upon 21, and this is precisely what the value of alpha into beta is. So this is also verified. So now what I want you guys to do is please complete this question and the questions that are after this. I want to move on to the next topic. Alright, so complete this. You have any doubts, please let me know on the group. Chalo, I'll move on to the next one.